Have you ever paused to wonder what's really happening when you flip a switch and your fan starts spinning? Or when you press a button and your room fills with a gentle breeze? What's the secret behind that familiar whir that cools you down on a hot day? Or how your favorite toy car suddenly zooms across the floor, racing faster than you can chase it? It might seem like magic, but it's actually the work of an electric motor. A small but mighty device that's quietly working behind the scenes in so many things you use every day. Electric motors are everywhere, woven into the fabric of our daily lives. They're in your kitchen, your living room, your school, and even in your pocket. From the blender that whips up your morning smoothie, to the elevator that takes you up to your apartment, to the tiny fan inside your computer keeping it cool, motors are the invisible force that transforms electricity into movement, making modern life possible. Think about your day. From the moment your alarm clock buzzes you awake, to the coffee machine brewing your first cup, to the fan that lulls you to sleep at night. Motors are there, working tirelessly in the background. Learning about motors is like getting a backstage pass to the inner workings of our world. Factories, hospitals, and even amusement parks rely on motors to keep things running smoothly. At the heart of every motor is a fascinating dance between electricity and magnetism. When these two forces interact, they create motion, spinning, whirring, and zooming in ways that power our lives. By exploring how motors work, you'll start to see your everyday gadgets in a whole new light, appreciating the clever engineering that makes them tick. So get ready to uncover the science behind the spin, the whir, and the zoom. You're about to discover the hidden world that powers so much of what you do. The electric motor is truly one of the most important inventions in history. Let's dive in and see how it all works. So what is a motor? Simply put, it's a machine that turns electrical energy into mechanical energy, motion. Plug in a fan, and the motor inside turns electricity into spinning blades and a cool breeze. Motors are everywhere, doing one main job: creating motion. They can spin wheels, pump water, or make your phone vibrate. Think of a motor as the translator between electricity and movement. It's like your body turning food into energy to run. Instead of air or food, motors use electricity to get things moving. This transformation is what makes motors so useful in thousands of devices. Next time you see something moving and plugged in, you'll know a motor is at work. It's a simple invention that powers our world. How do motors turn electricity into motion? The secret is magnetism. But how does this invisible force actually make things move? Let's break it down step by step. Magnets have north and south poles. Opposites attract, likes repel. This simple rule is the foundation of how motors work. And it's all about the way magnetic fields interact with each other. When electricity flows through a wire, it creates a magnetic field, turning the wire into an electromagnet. The stronger the current, the stronger the magnetic field. This means we can control the magnetism just by adjusting the electricity. Inside a motor, an electromagnet, called the rotor, sits next to a permanent magnet, known as the stator. The rotor is designed to spin, while the stator stays still, creating a perfect setup for movement. When powered, the electromagnet's poles interact with the stators, causing a push or pull that starts the rotor spinning. This interaction is what transforms electrical energy into mechanical motion. To keep it spinning, the direction of the current is switched by a device called a commutator. This flips the poles of the electromagnet at just the right moment, creating a continuous push-pull effect that keeps the rotor turning. This rapid switching happens many times per second, making the motor spin smoothly and efficiently, without stopping or jerking. It's a non-stop magnetic dance that powers everything from fans to cars, washing machines, and even electric trains. Motors are everywhere, quietly working behind the scenes. The key is the controlled, invisible forces of magnetism and electricity, working together to create visible motion in our everyday lives. That's the magic of motors, turning silent, invisible energy into powerful, useful movement. Next, let's see how we can predict which way a motor will spin, using a simple rule you can try yourself. Scientists and engineers use Fleming's left-hand rule as a powerful tool to predict the direction of motion in electric motors. This clever rule helps us understand how electricity and magnetism work together to create movement, turning invisible forces into something we can see and use every day. To try it yourself, simply hold up your left hand and make a pretend gun shape. Your first finger should point straight ahead, your second finger sticks out to the side at a right angle, and your thumb points up. It might feel a bit awkward at first, but this gesture is the key to unlocking the mystery of how motors spin. Each finger on your hand represents something important. The first finger, pointing forward, stands for the magnetic field, which always goes from north to south. The second finger, pointing sideways, shows the direction of the electric current flowing through the wire. And your thumb, sticking up, represents the force or motion that results from the interaction of the magnetic field and the current. This is the direction the motor will actually move. So if you know which way the magnetic field is pointing and which way the current is flowing, your thumb will show you exactly which direction the motor will spin. It's like having a secret code to predict the future of machines. This simple, handy trick makes it much easier to visualize the invisible forces at work inside every electric motor. It's a great way to connect what you learn in science class to real-world technology. Fleming's left-hand rule helps us see how electricity and magnetism, which we can't see with our eyes, combine to create real movement in machines all around us, from fans and toys to trains and cars. Next time you see a motor in action, try using the left-hand rule yourself. Hold up your hand, line up your fingers, and see if you can predict which way the motor will turn. It's a fun experiment you can do almost anywhere. This clever trick is more than just a classroom demonstration. It's a real tool that scientists and engineers use to design and understand the machines that power our world. With Fleming's left-hand rule, you can predict, explain, and even impress your friends with your knowledge of how motors work. Science really is cool when you can see it in action. Let's talk about DC motors, the kings of battery-powered gadgets. DC stands for direct current, the kind of electricity that flows in one direction, like from a battery. You'll find DC motors in remote control cars, drones, electric toothbrushes, and more. They're small, lightweight, and perfect for portable devices. DC motors use a commutator and brushes to switch the current and keep spinning. As the coil spins, the commutator reverses the current, flipping the magnetic poles and maintaining rotation. Speed is easy to control. More voltage means faster spinning. That's why DC motors are great for toys and gadgets where you want to change speed. They're simple, reliable, and incredibly versatile. Just add a battery and you've got motion. Next, let's look at the motors powering your home. Meet the AC motor, the workhorse of homes and industry. AC stands for alternating current, the electricity from your wall outlets that switches direction many times per second. AC motors power washing machines, refrigerators, air conditioners, and more. The most common type, the induction motor, uses a rotating magnetic field to spin the rotor, no brushes needed. This design makes AC motors durable and low maintenance. They're perfect for heavy-duty, long-running tasks. While their speed isn't as easily adjusted as DC motors, they're reliable and efficient. AC motors are the backbone of our infrastructure, running everything from fans to massive pumps. They're the strong, silent type, working behind the scenes. Now let's see how different types of AC power affect motors. AC motors come in two main flavors, single-phase and three-phase. Single-phase power is what you get from home outlets. One wave of electricity, perfect for blenders and fans. Single-phase motors need a little help to start, often using a starter winding or capacitor. For big machines, factories use three-phase power, 3 overlapping waves for constant, powerful turning. It's like 3 people pushing a merry-go-round instead of 1. Three-phase motors are naturally self-starting, powerful, and efficient. They're used in elevators, industrial machines, and commercial buildings. You won't find three-phase power at home, but it's essential for industry. These motors are the muscles of our modern world. Whether single or three-phase, AC motors keep everything moving. Now let's check out some high-tech motor designs. Modern motors include brushless and stepper types. Brushless DC motors use electronics instead of brushes, making them quieter, more efficient, and longer lasting. You'll find them in drones, computer fans, and cordless power tools. They're the top choice for reliability and performance. Stepper motors are all about precision. They move in tiny, exact steps instead of spinning smoothly. Printers and 3D printers use stepper motors for perfect positioning. An electronic controller tells the stepper motor exactly how far to move. Stepper motors are essential for robotics, cameras, and medical devices. Both types show how far motor technology has come. Let's see what the future holds for electric motors. Electric motors power nearly every part of our lives, from alarm clocks to electric cars. They've revolutionized industry automation and transportation. The future is even brighter. Electric vehicles are replacing gas engines, offering quiet, clean, instant power. As batteries improve, we'll see more electric cars, buses, and even planes. Motors are also at the heart of robotics and smart homes, making life easier and more efficient. Every whir and buzz is a reminder of the science at work. The electric motor is a perfect example of how simple principles can change the world. Be curious. Look around and guess what kind of motor is inside your gadgets. The story of the electric motor is still being written, with new chapters ahead. Thanks for joining this electrifying journey.